Day 13. Let's build a dog versus cat classifier using a convolutional neural network, which is CNN. This project involves classifying images of dogs and cats into their respective categories using deep learning. We'll use the CNN for feature extraction and classification in this case. So for this example, we'll use the Kaggle dogs versus cats dataset, which contains images of dogs and cats. The dataset can be downloaded from Kaggle. I provided the URL and I'll show you in a minute. But for demonstration purposes, I'll outline how you can structure and implement this model. So let's go and get started. So first we need, this is the URL, this is the dataset URL. So we'll need this. You can download it from here. I've already downloaded it and kept it in my document. I can open it and show you. It has images of cats and dogs on which it is trained. I have a test set, I have a training set, and both of them have images of cats and dogs. Also, I have an image of a dog, which is my test image, just to test afterwards. So we're going to go through first training the model, and then we will evaluate, and then we'll test with a particular image to see if it classifies properly. So let's get started. I've already created day13.py with nothing inside it. So first step, as usual, is importing necessary libraries. So first we'll import the necessary libraries. Import TensorFlow STF. Now TensorFlow provides the tools for building and training neural networks. So that's why we're using that. We'll also from TensorFlow Keras import layers and models. Again, it's part of all TensorFlows. TensorFlow Keras pre-processing image will import the image data generator. Now this image data generator is a class in Keras used for image data augmentation, which improves the model's ability to generalize by creating variations in the training data. Next, we'll also import matplotlib, pyplot as plot used for plotting the training and validation accuracy loss curves. Next, we need the data. This is the URL for the cats and dog data set that I'm using. And you can, what we'll do here is we'll define paths to the data set and update this path with your actual location. But I'm going to give these, which are mine. Training directory is the training directory right here. So I'm going to say training set. And my validation directory is the test set right here. So I'm going to assign to that. Now next, we need to define the image data generators for data augmentation and rescaling. So for that, I'll create a variable train data gen and initialize our image data generator. So first, it needs is the rescale pixel values which are from 0 to 255 to 0 to 1. So we're going to convert that using this rescale function. Next, we'll have give a rotation range equal to 40, which randomly rotates images just so we can get better testing. Then I'm saying width shift range equal to 0.2, we're randomly shifting images horizontally. Also height shift 0.2, we just will randomly shift images vertically. Next, we have shear range equal to 0.2, which randomly adds shear to the images. Then we have zoom range, which randomly zooms in on images. Horizontal flip equal to true, which randomly flips images horizontally. Find fill mode nearest, which will fill pixels that may have been lost after transformation. So that will fill the pixels here. And that's it. So the trained data gen here, it prepares the training data by applying data augmentation techniques such as rescaling, rotation. We're also doing zoom and horizontal flipping here. So it helps the model generalize better by artificially creating new training examples. Now let's look at our validation data gen. For the validation data, we just rescale. We don't have to do any data augmentation. So I'll say validation data gen image data generator rescale equal to 1 point slash 255. This will convert everything from 0 to 255 to 0 to 1. So we're done with that. Next step is loading the training data and validation data. So first we'll call the train generator and we'll say train data gen from above, flow from directory. We'll give our train directory. We'll give the target size of 150 by 150. What it does is it resizes all the images to 150 by 150. We'll give a batch size of 32, class node equal to binary, and that's it. So that will create our train generator. Now, also we have to create the validation generator, so we can do that using same flow from directory. Now this flow from directory loads images from directories. That's why we have to first give the path of the directory. Next thing, we are so each subdirectory within this train directory or validation directory should correspond to a particular class, which is cats and dogs. That's why we have cats and dogs inside here. And then we give a target size of 150 by 150, which resizes all the images to 150 by 150 pixel. Batch size 32, it loads 32 images at a time in batches. And then class mode is binary. What this does is specifies that this is a binary classification problem. In our case, it's dog or a cat. Next step, define the CNN model. Now first we'll define the model. It's a model dot sequential. Then we're going to say we'll create the first convolutional model. Now to create the first convolutional model, we'll say model dot add, and we are saying layers dot con2d. Now con2d creates convolutional layers to extract spatial features from the images. The first layer has 32 filters. The second layer has, so we'll create like multiple layers, and I'm gonna do the first model. We are gonna give the size 3 by 3, which is the kernel size for all the layers. And the activation style, we're using ReLU activation. And input shape, since we are converted that 150 by 150, we are specifying 150 by 150 here. So next we are doing model dot add layers, adding max pooling 2D to 2 by 2, which reduces the spatial dimensions of the feature maps by taking the maximum value in 2 by 2 blocks. Then we are gonna do that again for the second layer. We're doing the same thing, but the second layer has 64 filters. So 64, the rest of the stuff is still. Then again, max pooling 2D, 2 by 2. Now we're going to add another convolutional layer, third convolutional layer, which has double of this, which is 128 filters. We're going to add convolutional 2D 128, the same number of filters we're going to add. We're going to add max pooling 2D. And then finally, now we're going to flatten the output from the convolutional layer and add fully connected layers. So how do we do that? We will say model dot add layers dot flatten function, and then to these layers we are calling the dense function, which is fully connected layers. The first dense layer, which is this one, has 512 units with ReLU activation. Then we are adding another dense layer. We are giving one activation is sigmoid for this particular case. This is the final dense layer, which has only one unit with sigmoid activation to predict a binary outcome, which is cat or a dog. Next, let's go ahead and compile the model. So once our model is created, everything is ready, we can call the model.compile function. And optimizer, in this case, we are using Adam. Adam optimizer is used for efficient gradient based optimization. So that's why we're using that. The loss equal to binary cross entropy, which uses, the reason we're using binary cross entropy because it's a loss function which is suitable for binary classification. And the metrics we use here is accuracy. Next, we're going to print a summary of the model by saying model.summary. This will give us a model of this particular, a summary of this our model. Now let's go ahead and train the model. Now to train the model, first you will call history equal to model.fetch, where we're going to say the generator is train generator. Now this trains the model on the training data for, let's see how many epochs. So steps per epoch is 100 steps is what we're taking, which is batches of per epoch. We are doing 20 epochs, and validation data is validation generator, which we have created above. Validation steps equal to 50, where number of batches for validation, and that's it. So these are something that you can actually customize yourself based on your need, but this works pretty well for me. Next is plot the training and validation accuracy and loss. So for that, I'll first say accuracy equal to history.history accuracy. Next, I'm gonna say val accuracy equal to history.history val accuracy. and then I say loss equal to history dot history of loss, and then value of loss is history dot history val loss, and epochs equal to range of length of uh, the accuracy ACC. Then I'll plot the figure. I say plot dot figure, and the figure size is 12 by 6. I'll give this size. I will give the subplot of 1 to 1. I'll plot the epochs, the accuracy with B, and label as training accuracy. Then I'm going to do the same thing for epochs of valac R and validation accuracy is what the label will be. Finally, I'm going to give also the title, which is training and validation accuracy to it. And now to show the legend, we can do plot.legend. Next, plot subplot. We'll do the subplot for this. 1 to 2, plot epochs, loss B, label equal to training loss. This is the first one was for the training accuracy. This is for the training loss. So I'm going to go through this and do the exactly same thing for training and validation loss, show the legend, and finally I'll show the plot. So that kind of takes care of plotting our plot training and validation accuracy and loss. So that takes care of plotting training and validation accuracy and loss. So next thing that we will do is we'll test the model with a new image. To do that, I'm gonna first from TensorFlow Keras pre-processing, I'm going to import an image because I'm going to use my own image as I mentioned. I'm going to import numpy as np, and I'll create a function which is predict image, and to this kind of loads and pre-processes a new image and then makes a prediction using the trained model. So it takes model and image path. Then I'm going to say image equal to image dot load image, give the image path to this, and target size 150 by 150. So after loading the image, I am going to change the image size into 150 by 150. Image array equal to image which I've got, image to image array, and change it to image. So this converts the image to an array. Next, I'm going to add the batch dimensions by saying np with numpy expand dimensions, pass the image array, and axis equal to 0. Then I'm going to divide by 255. This will normalize the image, which will rescale again to 0 to 1. Then finally, I'm going to say prediction equal to whatever model is provided to me. I will run the predict function on that based on the image array that I created here. And then if prediction is 0 is greater than 0.5, that means the image is predicted to be a dog with a confidence of whatever prediction it is. Else, the image is predicted to be a cat with a confidence of 1 minus prediction 0 0.2f. So depending on what the number that I get is 0, if this is above 0.5, then it's a dog. If it's less, then it's a cat. Next, let's test it. So I passed the test image here to this function, and I gave the model that we've created above. Save it, and let's go and run it. So to run it, I'll say python day13.py. So since we have a lot of images that we have given it, so it's going to take some time looking at all those images. So I'm going to pause it here and come back once this is done. So after running the 20 epochs, as you can see, it will display me the graph here, or plots which we mentioned. We are displaying the two plots. One is training and validation accuracy, and one is training and validation loss. So they get displayed here pretty nicely. And if you see, the order is pretty nice. The graph looks pretty decent. And if you run it for less epochs, you'll probably see the difference, because more the training, better the output is. Now I'm going to close this and look at our confidence level. The image is predicted to be a cat with a confidence of 0.52, even though I provided a dog, which means my training was not good enough. It probably stretched the image or something and then gave me a prediction of 0.52. So there you go. So we created a project where we build a model which can predict if it's a dog or a cat, and that was done using CNN, which is convolutional neural network. So I hope you got it working too. If not, let me know in the messages and I'll get back to you. Thanks.